So these problems we're starting. As I was saying Friday, these are kind of culminating type questions. There are some prerequisites from Algebra 2 that you are going to need for these questions. Obviously, this one up here is a quadratic, right? Because we see something kind of like 2x squared. Come on, computer. Don't do this today. Plus 3x plus 1 equals 0. So we're going to have to need to be able to solve quadratics. So factoring can come into play. If you remember how to complete the square, we might need that, or quadratic formula from time to time. But basically, the goal here is to do the same thing you would do if it was just x, which is we have to find every single answer to this question that exists. So what do you think is the first thing we're going to have to do here? Factor it, yeah. What would this factor into? So this will factor, well, what two numbers multiply to 2? 2 and 1, so we'd have 2 sine x and 1 sine x. And then what two numbers multiply to 1? 1 and 1. Both are positive. Outsides give us 2 sine, insides give us 1 sine. Yes, that would add up to 3 sines. So this does factor. Once you have it factored, what do you do with each of these? You set them separately equal to 0, and then we're going to solve them both separately. So this one, when you minus the 1 and divide by 2, we get sine x equals negative a half. This one we solve and we get sine x equals negative 1. If the sine wasn't there, we'd be done, right? What's the difference now? How do we get rid of the sine? Now you got to take the inverse. So here's where the inverse functions come into play. The goal here now is basically to find every single angle, because these are all going to be lowercase, every single angle where sine equals negative a half. Well, this one we can use our table. When does sine equal a half? 30. It's a negative a half, so what quadrants is sine negative? Third and fourth. So, what's a 30 in the third? 210. So x could equal 210. 30 in the fourth? 330. And yes, we should put the plus 360 in. I'm not going to have you put the plus 360 in because that would be a lot of plus 360 n's. Just know that, yeah, we're probably supposed to. Okay? Over here, when does sine equal negative 1? 270. I'm going to kind of change the rules and basically say, I want you to find every single answer somewhere between 0 and 360. So we're not going to find all for like all of the answers. We're just going to say, what are every single answer where this is true between 0 and 360. Now, don't think you're going to have to factor every single time. You're not. Some problems are a lot easier than others. I mean, you might just have something that says, what is 2 sine x plus, we'll do minus 1 equals 0. I don't have to factor this one. What's the only thing I have to do here? Add 1, divide by 2. You're just going to get sine x equals 1/2. So then you say, when does sine equal a half? Well, 30 degrees my reference angle. First and second is where sine is positive. So x could equal 30, and x could equal 150, and you're done. So some problems are going to be a whole lot easier than others. You will run into, once in a while, a problem that looks like this. And what's wrong with this one? You've got different trig functions. You can't factor, you can't do anything with these to actually start solving it if you have different trig functions. So here's where you're going to have to go back to your proof chapter and say, is there a substitution I could make? The goal is not to simplify as much as it is, I need to make all the trig functions the same. So I either need to figure out a way to turn this sine into a cosine or this cosine squared into a sine. Which one do we know how to do? The cosine squared. I can change that cosine squared into a what? A 1 minus sine squared. Yes? So far, so good? Okay. Distribute. 2 minus 2 sine x, sine squared x, plus sine x, plus 1 equals 0. Combine like terms, we'd have negative 2 sine squared x. We've got that plus sine x. And now we have, what, 3? So far, so good? Now we have to factor, or quadratic formula. I never like to factor when my a value, the one that's squared, is negative. So I would multiply everything right now by a negative 1. Just to make this positive. Okay, so we factor. So 2 would be 2 sine x and 1 sine x. And then we have 3, so we have a 3 and a 1, and we have to subtract to get 1. So where's the 3 going to go? If you put it here, I'd have 6 and 1. I don't want that. If I put it here, I'd have 3 and 2. So that'll work. So what are my signs? I have to end up with a negative 1, so the 3 has to be negative, and that's positive, right? So far, okay? Okay, solve this. When is this going to equal 0? Well, add the 3, divide by 2, you'd have sine x equals 3 halves. When does sine equal 3 halves? What is that as a decimal? 1.5. When does sine get to 1.5? Think about the graph. Never does. What's the highest sine ever gets to? Highest it ever gets to is 1. So when does it get to 1.5? It doesn't. So this part yields no answers. That doesn't mean there's no solution. It just means this doesn't equal 0. Because remember, why are you able to do this step right here? Why are you able to do from here to here? Well, what it means is once I factor it, I get it to this point where it says I have this number, I don't know what it is, times this number, I don't know what it is, but the answer is 0. If two numbers multiply to equal 0, what has to be true? One of them has to equal to 0, doesn't it? So we say, all right, what could make this 0? And then what could make this 0? Well, what we just showed is this part never can equal 0. It's never going to happen. This part must be the one that equals 0. So when does sine equal negative 1? 270. 270 is actually the one and only answer to this. A question like this, how many answers typically, just between 0 and 360, are we potentially looking for? Actually, it's 4. Why is it 4? Because there's 2 answers to here, right? And then this sine x equals negative 1. How many potential answers is this going to have? 2. It could be like a half, right? Or negative half, and it has 2 answers. This could also yield 2 more different answers. So we could be, for some problems, looking for up to 4 answers just between 0 and 360. Yes, technically we should put the plus 360 in, so then there's an infinite number of answers no matter what, but we're going to have those. So here's what I mean by culminating. Take this problem right here. What pieces of knowledge did we need to solve that? Well, we had to make a substitution, so we needed chapter 3, the proof stuff. What else did we need? Factoring. What do you mean? Okay, we need to know our table and our quadrantals to be able to solve this, right? We need to know our quadrants. We also need to know, like, the graphing chapter, because that kind of helps us figure out when does sine equal 3 halves. This one problem took a lot of different types of questions. Yes, there is going to be some substitution involved. Yes, factoring's involved. Do you think there's going to be, when we get to here throughout this stuff, every single problem is going to be factorable? No. So what might we have to be able to do? We have to have a different method of solving quadratics. So we better know the quadratic formula going forward. That's going to come into play. We're going to need to know our table. We're going to need to know how to do inverses. We need to know when our functions, what quadrants things are positive to figure out what the answer. So these problems right here, they take information from chapter 1 that we need. That's where we got our table and our quadrants from. We needed chapter 2, the graphing, to kind of figure out, all right, sine doesn't equal 3 halves. It can't equal that. So we knew that. And then chapter 3, that was the proofs, right? Chapter 4, law of sines, law of cosines. We didn't really use that stuff in here. And then we also need stuff from algebra 2. These problems require a lot of different smaller pieces of information to be able to solve. And I will warn you, sometimes you're going to get some really nasty looking problems. Oh, does that look nasty, doesn't it? Like that looks like something that's really hard to factor. I mean, just to factor it, what 2 numbers multiply to the square root of 3? Holy cow, that's a lot of different things. Or, isn't it, how about just square root of 3 times 1? I'm getting there. To factor this one, take this tip. What's square root of 3 times square root of 3? All right, so what 2 numbers multiply together to get the square root of 3? How about just square root of 3 and 1? Right? This times this would equal this, right? Now, what would happen if I did the square root of 3 times 1? So let's put the square root of 3 here and the 1 here. What do my outside numbers get me? What's square root of 3 times square root of 3? 3. 1. Do those add up to 4? Yes, sir. So, with some of these, why, if I am the author of this book and I want to find some problems that actually do factor and give me numbers like this, once I get it to here, isn't that kind of a pretty question now? I can solve that. When does tangent equal square root of 3? Second, fourth quadrant. What's my reference angle? 60. So 120 and 300. This one over here, I would get tangent is going to equal minus the 1 divided by the square root of 3. That actually simplifies to this. So tangent x equals negative square root of 3 over 3. Well, that's 30. Again, 2 and 4, so 150, 330. Why did I have to start with such a nasty question in order to get nice answers like this? Well, think about the numbers in our table. There's some nasty numbers in our table, isn't there? So if I want to end up with tangent x equals negative square root of 3 over 3, we know how to solve that in our head. It's in our table. And tangent x squared of 3. If I start with that and work back, do you think the beginning question is going to look pretty to start out with? Probably not. So don't get shocked when you see some ugly looking answers or ugly looking problems. Okay? Ready to try some of these? Let's call it a day. All right, page 267. Doesn't sound, I don't know why. Again, you can ignore all directions. We're not doing these in radians. That's where you say thank you. Because we could do these in radians. I don't want to. It's not that much fun.
I don't know where you're reading this. It says you have to put it into radians as the directions, but I'm not reading it.
It says right above number 1, it says find the exact solution for the interval from 0 to 2 pi. Those would be radians. All right, I want to stop you real quick. Remember how we did chapter 1, we did chapter 2, we did chapter 3, we did chapter 4, and then I said chapter 5 was just more proofs with different identities, and we all agreed let's just skip chapter 5. Well, everybody look at number 32. What do you notice about 32? That whoa, whoa, whoa! What do we? What? It's this thing. Right there. In order to solve that question, there's an identity you need in chapter 5. We skipped chapter 5. So for this whole assignment, if you see that, skip that question. Which means, like if you're looking at that whole assignment, 1 through 40, what would be the first question you'd probably skip? 30? Yeah, we'd skip 30, we'd skip 31, we'd skip 32, 33, 34, 38, 37. So anything with a 2x in there, like sine of 2x, cosine of 2x, yeah, we're definitely going to skip those because otherwise I'm going to you'd be forced to look back at chapter 5, find the identity, and then you could do it. But I'm not going to worry about teaching those identities just to do these problems.
Whoever had this book before me, Lexington, he gave the lines through the numbers.
Yeah. There's, yeah.
So my guess is we're only doing it even because only the even ones are crossed.
Wow, it's almost like you can read my mind. It's almost like I kind of used similar lesson plans from years past.
Yeah.
It just makes my life a little easier. Why? It worked then. Why change it now? Yeah, we're doing the evens. Basically 2 to 40 even, except you can skip all the ones with the 2x. So yes, you can skip 30, 32, 36, and 38. So pretty much 2 to 28 even, and 40. So this is really the easiest way to that's the easiest way for you to write down what the actual assignment is. Or you can write out 2 to 40 even, but you can skip 30, 32. It's an and.
No, it's already on the board. You can't change it.
Yeah, it's permanent. It's permanent.
Yeah, it's which way now.
No, you have to do that one.
No.
Yeah.
Thanks, Natalie.
You gotta do that one.
It looks like I'm skipping 2 problems today.
Here's basically what I want you guys to do. I want you to try these. There's going to be a lot of questions tomorrow. I know this. I am planning on spending the majority of tomorrow going through almost this entire assignment. So if you get stuck on something, don't freak out. Don't think you have to have this all done. Try them. But I expect you to get stuck from time to time. Okay? So yes, we are going to go through this entire homework assignment tomorrow in class.